All right, these are the answers to the Term 3 exam review. For the first one, we're told that we're asked to find the limit of this when f of x equals that. So right away, we want to recognize that this is the definition of a derivative. Okay. So when I see this, what they're really saying is, what is the derivative for this function? It's kind of a roundabout way. I wish they'd just be, straightforward, but that's what they're asking. So derivative of this is a chain rule. E is the outer function. The derivative of E is its own thing, so we're going to repeat that, times the derivative of the exponent, which is 8x. Okay, so that's the derivative of that. And then the derivative of 5x is just 5. So that would be our answer right there. Then we're asked to find the derivative of these. So for this one, again, this is a chain rule. Sine is the outer function. So the derivative of sine is cosine, leave the inside alone, times the derivative of 4t cubed, which is 12t squared. For b, this is also a chain rule. This is inside of the third power, so the derivative would be bring the 3 down, leave this alone. So we're going to leave that as cosine x plus 2x cubed, times the derivative of that, which is negative sine plus 6x squared. And we want to make sure to put parentheses around it because we want the whole thing multiplied, not just a piece of it. For this one, we have x to the 4th inside natural log. So for the derivative, it's going to be the derivative of natural log, which is 1 over whatever's inside of it, times the derivative of what's inside of it. And if we do a little simplifying, that simplifies down to 4 over x. For this one, it's chain rule, but this time natural log is inside the 4th power. So when you do the derivative of this, you're going to do the 4th power first. So drop the 4 down, drop to make it a 3, keep the natural log the same, times the derivative of natural log, which is 1 over x. And then here we have e to the square root of x power. So when I do the derivative, we're going to do the derivative of e first, which is its own derivative. So we repeat it, times the derivative square root of x, which is 1/2 x to the negative 1/2 power. Okay. All right, down here we've given this graph, and we're asked to find a bunch of these things here. So first off, we're asked to find the limit as x approaches -2. So as we come towards -2 from the left and the right, we're approaching a value of 3. What's the limit as x approaches 1? So as I approach 1 from the left, I'm heading to 1. If I approach 1 from the right, I'm heading to -1. There is a disagreement there, so that limit does not exist. F prime 2 wants to know at 2, what's the slope of the tangent? How is this changing? You can see we have a horizontal tangent at 2, so its slope would be 0. The limit as x approaches 3. So as I come towards 3 from the left and from the right, we're approaching this value of 0. What's the limit as you approach 4? So as you go to 4, you see how both from the left and the right, we're heading up towards infinity. So you could say that that does not exist because we're not really heading to a limit. But if you said positive infinity, that's okay because both of them are heading to that value. F of 1 wants to know where the function is at 1, and you can see that the dot at 1 is right there at -1. F prime -1 wants to know what the slope of a tangent line at -1 would be, and we can see since this is linear, it's just going to be the slope of that line. It's down 2 over 3, so that derivative would be -2/3. And then we want the derivative at -2, but at -2 we have a sharp turn. So since we have sharp turn, that derivative is undefined. So nice little review. Hopefully that felt pretty comfortable. Then we get to number 4. We have a particle in motion. Velocity is -t squared plus 9t minus 20. So I take the calculator. We're going to go right to y equal and put that right in there. Okay? And we were told that we have an initial position of 3 feet left of the origin. So 3 feet left, that was a key. That really means that your position is -3. Okay? So that's important for us to kind of be aware of that. All right, so A, is the particle speed increasing, decreasing, or neither at t equal 3? So what we want to do is find out what the velocity at 3 seconds is and find out what the acceleration at 3 seconds is. All right. So if we put 3 in here, we're going to get negative 9 plus 27, that's 18, minus 20, that's a negative 2. Negative 2 feet per second. All right, that's our velocity. It doesn't tell us anything yet. Let's do the acceleration. Acceleration is negative 2t plus 9. If I put 3 in there, I get negative 6 plus 9. That's positive 3 feet per second squared. All right, so I have a negative velocity, a positive acceleration. So our speed is decreasing because v of 3 and a of 3 have opposite signs. All right. B, what is the total distance traveled from 0 to 4? Okay, so when we do total distance, we're going to integrate our velocity. But if we integrate the velocity just as is, then anytime it's moving to the left, that negative velocity will cancel out the distance we traveled to the right. And I don't want those distances canceling. I want to actually know what the total distance was. And so to do that, we're going to put our velocity in absolute value. So that way, it's just measuring the amount, the speeds we went, and not necessarily the direction. So on this screen here, I go math 9, 0 to 4. I can go math, slide over to number. You see absolute value is the first option there. And then I'll go alpha trace y1, and then dx. Okay. So there's my integral of the absolute value of this from 0 to 4. It gives me a total distance of 29 1/3. What is the particle's position at t equal 4? So now I got to go back and say, well, my original position was negative 3, and I want to find out how my position changed. So this time I do want positives and negatives to cancel each other. I want to know what the displacement was. And in order to do that, I just integrate from 0 to 4 the regular velocity. Okay, so this way it's moving to the left, that'll show up as a negative, positive will show up as a, right will show up as a positive. So negative 3 plus math 9, 0 to 4 of just simply y1 dx. We get negative 32 1/3. What is the particle's average velocity on the interval 0 to 7? So now if I want an average velocity, what I'm going to do is go 1 over the amount of time here. So 7 minus 0 would be 7 times the displacement. So this is your average value kind of function. Anytime you're asked for the average of something, you integrate that something. So I want average velocity. I'm going to integrate velocity from here to here. And then we spread it out evenly over the amount of time to get the average. Okay. So for us, we're going to go 1/7 times math 9, 0 to 7 of alpha trace y1 dx. I get negative 4.83 repeating. Negative 4.8, we'll go 3.3. That's our average velocity. And then this one says, is the particle moving towards the origin or away from the origin at t equal 4? So we already know the position at 4. Our position was negative 32 1/3. So we know that we are to the left of the origin, okay? Now that doesn't tell you anything, it just tells you where you're at. So if you had the origin right here, okay, there's 0, we know that we're somewhere over here. So this is our position. But we don't know if we're moving towards it or away from it. So the thing now is to say, well, what was the velocity at 4 seconds? And if it's a positive velocity, we're moving to the right, that'd be towards it. If it's a negative velocity, we're moving to the left, we're moving away from it. Again, if I had been over here, then it would just be the opposite, right? So again, you have to have a connection between where are you at and then which direction are you going. So our velocity at 4 seconds would be negative 16 plus 36, which is 20 minus 20. Just real quick, let me, yeah, so when I put 4 into this, here's how sneaky this is. We end up with 0. So are we moving towards the origin or away from it? We would say neither. We are at rest because that velocity is 0. But if it had been positive, we'd be moving towards the origin. If it would have been negative, we'd be moving away. And that's part 1.